Alright, I'm not sure where that cut off, but this ended up being 10 root 3, so pause the work and see if you can make sense of that. On number 7, I'm going to do C. So 7C says the square root of 10 in parentheses 3 plus 2 root 10. And it says simplify again. So we have to take this and simplify it. So one thing we can do is distribute that root 10. So that's how that would end up looking. This is 3 root 10 plus 2 root 100. Just 3 root 10 plus 2 times 10. Should be 20 plus 3 root 10. That's how I would write that. 20 plus 3 root 10. We can't combine these. Those are not like terms. That would be like combining a 2 plus a 2x. You can't combine those. Those are not like terms. So that's as far as we go with 7C. Alright, on to other things. On number 8, I wanted to do A. So it says simplify. It's 5 plus root 2 times 4 plus root 2. Alright, in this scenario, for 8, you have to FOIL. Should bring back good memories of algebra class. And root 2 times root 2 is just 2. Okay. So we've got 22 plus, now these you can add together because they have the same, that's like adding 5x plus 4x, you would get 9x. So 5 of these plus 4 of these is 9 of these. So 5 root 2's plus 4 root 2's is 9 root 2's. That's as far as you can go. You cannot combine these together because they're not like terms. That was 8. Let's keep going. Number 9, I'm going to do G. 9G. It says 7 minus 2 root 10 squared, and I have to simplify that. What you cannot do, and this is done so often, it's just frustrating. You cannot just take the square and go like that and like kind of distribute the square because there's 2 terms here. You can only do the distributing of the square if this was like 1 term. If this was 7 times 2 root 10, then you could apply the square to everything in here. But because of that minus, it's going to be a little different. You have to do 7 minus 2 root 10 times 7 minus 2 root 10. That's what it means to square that. So now we will do 7 times 7, 7 times 2 root 10, so 14. Okay, now another one of those, and then multiply these two together, which leaves you with positive 4 times root 10 times root 10, which is 10. So that's the last part of the FOIL there. So this ends up being 40 plus 49, negative 14 root 10 minus negative 14 root 10. We can combine these together. Negative 28 root 10. For 10, number 10, I wanted to do D. This is 10D. 10D says 2 root 2 plus 1 times 2 root 2 minus 1. Interesting. Now these are called complex conjugates of each other. It's the same It's the same thing, only this one's positive and this one's negative. So let's see what happens when you multiply complex conjugates together. So 2 root 2 times 2 root 2 is 4 times 2. That's the first, that's these two multiplied together. And then you got minus 2 root 2. Then you got plus. And we're multiplying this one. Plus 2 root 2. So I'm just foiling. And then you've got minus 1. So first, inner, outer, last. Foil. Now these cancel out. And you end up with 8 minus 1. 7. So what happens when you multiply two complex conjugates together, where they're the same thing here, except this is positive, this is negative? It cancels the square root out. That's going to come into play when we rationalize a denominator. So now I'm on to 3b. Exercise 3b. Let's see what we can do for exercise 3b. It says write with an integer denominator. 1 over root 3. Right? With an integer denominator. Now, this has a irrational denominator. Root 3 is irrational. So, this question is asking us to it's called rationalizing the denominator. What you do is you multiply by 1. Like that. This is 1. When you multiply by 1, it doesn't change the value of the number. Like 5 times 1 is still 1. Sorry, I mean 5 times 1 is still 5. Doesn't change the value. So it's just a little trick. So you multiply across the top. You multiply across the bottom. Root 3 times root 3 is just 3. And now we have what the directions asked. The directions asked to have an integer denominator. And so this turned into this. We can verify that in our calculator. 1 divided by root 3 and root 3 divided by 3 are the same number. This one just has a integer denominator. I'm going to do 3e as well. Not 3e. This is 1e on 3b. It says root 2 over 3 root 3. So what I'm going to do is I'm going to multiply by 1. On top, that gives me root 6. And on bottom, that gives me 3 times root 3 times root 3. Just multiply across times 3. So root 6 over 9 would be how we'd write that one. Alright, now I'm on to 2a. It says write with an integer denominator. And it is 1 over 3 plus root 2. That's 2a on this. So what I'm going to do is I'm going to multiply by 1. That's 1. This is, if you put something over itself, that's a 1. It doesn't change the value of this. That's called the complex conjugate, where you want to rationalize the denominator. You just take that positive and turn it into a negative. And now let's see what happens. So on the top, you just multiply 1 times that. So that's 3 minus root 2. On the bottom, you FOIL. 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2. 3 times positive root 2 is positive 3 root 2. And then root 2 times root 2, and that's positive times negative, is minus 2. So you can put that all together, and you get 3 minus root 2 over, those cancel out, 9 minus 2, 7. So there it is. It's the same number. And we can verify that in our calculator. If I do 1 divided by 3 plus root 2. There it is. That's that. And now if I plug in this number into my calculator, 3 minus root 2 divided by 7. It's the same number. The difference is this one has a integer denominator. So that was 2a. I'm going to do skip now to exercise 3D. That takes care of our square root stuff. Should be review. Hopefully it's a good review that we're going over here. So now I'm on exercise 3D, and I'm going to do A with you. It says simplify k to the fourth times k squared. So now we're going into the exponent rules. That's just k to the sixth. You just add the exponents together. 1g c to the eighth times c to the m. All you can do here is do c to the 8 plus m as your answer. Number 2, I'm going to do 2a with you. It says simplify 7 over 8, 7 to the 8th power divided by 7 to the 3rd power. In this scenario, you subtract. So 8 minus 3 is 5. That's the answer. I mean, what's technically happening here is you got 7, 7, 7, 7, 7, 7, 7, 7, and on the bottom you got 7, 7, 7. So these are canceling out, and you're left with 5 sevens on top. That's really what's happening here. Let's do I. T to the m over t to the fourth. So all you can do here is write t to the m minus 4. That's the same thing. You take the top minus the bottom. 2k, x to the negative 2 over x cubed. Again, since they have the same base of x, all you can do is do negative 2 minus 3, which would be x to the negative 5th. So let's examine what's really going on here. This is x to the negative 2 over x cubed, which is like that. Because it's negative, you can move it to the bottom, but that changes the sign of the exponent, which is 1 over x to the 5th, which is x to the negative 5. Now that this is positive in the bottom, I can move it up to the denominator as long as I change it to a negative exponent. So lots of stuff going on there. Next, I want to do 3a. 5 cubed squared. Now once again, what this means is it's 5 cubed times 5 cubed. 5 cubed twice, which is 5 to the 6th. You multiply in this scenario. You can do the rest of those. I'm going to now skip to 5c. So I'm on 5c in the packet here, and it says 8. It says write as a power of 2. So 8 can be written as 2 cubed. That's what 8 is. 2 times 2 times 2. And 5d is 1/8. 1/8 can be written as 1 over 2 cubed. Alright, literally that means 1 over 2 times 2 times 2. So we can write that as 1 over 2 cubed which then can be written as 2 to the negative third. This, because it's positive there, we can move it up to the denominator, numerator, and change the sign of the exponent. If you don't believe me, 1/8, and then 2 to the negative third. Whoops. 2 to the negative third. It's the same thing. Same number. Alright. Next, I'm going to do 7C with you. It says write as a single power of 2. It's 8 times 2 to the t. Write as a single power of 2. So this is 2 cubed, which is 8, times 2 to the t. So now they've got similar bases. Now I can apply one of the laws where it says you can just add the bases. So 2 to the 3 plus t power. That's 7C. How about 7D? It says 2x plus 1 squared. So this is a power to a power, which means I can write that as 2 like that. So all I'm doing is multiplying these two powers together. And you could distribute the 2. This actually looks pretty good, but if you wanted to, you could distribute that 2 to be like that. And what else? How about 7I? It's 2 to the x plus 1 over 2 to the x. Because they have similar bases, you can subtract the exponents, top minus bottom. So this is 2 to the x plus 1 minus x. Now that's going to cross that off, and you just get 2. There you go. 2 to the 1. Well, you get 2 to the 1, which is just 2. X and negative x cancel out. Moving on, I'm going to do number 9A. It says express in exponent form with a prime number base. So you should have a knowledge of what prime numbers are. They're numbers that can't be divided by anything else besides itself and 1. So 32, I mean, you could, it's going to have a base 2. It's 2 times 2 times 2 times 2 times 2. That's 32. So we can write that as 2 to the 5th. How about 9E? 9E is 16 to the p. Now 16 is not a prime number, but we can rewrite 16 as 2 to the 4th. And now we've got a power to a power, so you can rewrite this as 2 to the 4p. That's a power to a power. Now we're done. We've got a prime number base. And I wanted to do 9J with you. 9J. Ooh, running out of time on my video. 25p over 5 to the 4th. We can write this with a base of 5. That is 5 squared. That's 25. So this is now 25 to the p power over 5 to the 4th power, which is 5 to the 2p over 5 to the 4th. And now because they have the same base, I can subtract. 5 to the 2p minus 4. I think that's as far as we need to go with that one. And I'm out of time.